Okay, today I'm going to discuss about the lesson work, energy and power. This is the 18th lesson in grade 10. So we have subtopics as we work, and then here 18.2 energy, and the last part is here power. So we are going to discuss about these three parts of the lesson. First, let's start with the work. You have learned before that an object is said to have done work if its position or shape changed under the action of a force applied on it. So, an object is said to have done work in which scenarios if the position or shape changed under the action of a force applied on it. Let's investigate further about work. If we place an object on a horizontal plane, as shown in figure 18.1, and apply a constant force of 1 Newton on it until it moves a distance of 1 meter along the direction of the force, the work done by the force is defined to be 1 joule. Okay. So here in the first paragraph, an object is said to have done work highlight the parts which I highlight. If its position or shape changed. Under the force. Okay. See the below image what has happened in there. So in first time it is placed in this place and it has changed its position. Okay. So the first thing position has changed from 1 meter. Okay. So due to what? Under the force, no? So what is the force? It's 1 Newton force. Under the 1 Newton force and position change from 1 meter. See? Okay. So, the work has been done in here. And what is the unit of the work? You know, when it comes to force, the unit is Newton, and when it's come to distance or displacement, the unit is meter. But when it comes to the force, the unit is joule. Here, see, it's joule. Okay, I missed something. This highlight joule. So it becomes 1 joule. Why? 1 Newton force along 1 meter. So 1 multiply 1, it becomes 1, and Newton meter, we write that Newton meter as joule. So the joule or Newton meter is the unit of work. Okay. So here, if a constant force of 2 Newton acts on the object until it moves by 1 meter in the direction of the force, then the work done on the object is 2 joule. Is it okay? It's 2 Newton multiply 1 meter. So it ended up as 2 joule. Okay, I'll draw it here and you to write it. Okay, 2 Newton. So multiplication, I have to put it like this: 1 meter equal 2 into 1 is 2, and the you can use this equation, this unit O. Basically we write this unit as 2 joule. Okay, it's 2 joule. Then similarly, if a constant force of 3 Newton acts on the object until it moves by 1 meter in the direction of the force as shown in figure below, the work done by the object is 2 joule. Sorry, 3 joule. 3 joule. Okay, like this, 3 Newton multiply 1 meter equals 3 joule. Okay. Therefore, work done by a force. Put this one in a box. Then force multiply displacement in the direction of the force. Okay. Shall we write the note? So you have to start from here. Write the topic of the lesson 18. This is a physics lesson. Work, energy and power. Then write 1 and work. First one we are going to discuss here is work, then energy, then power. So write 1 and then write work. So below it, write the things which I highlighted here. An object is said to have done work පොඩි ඉරි කෑල්ලක් ගහලා ඩෑෂ් එකක් ගහලා position or shape change under the force. The object එකක් මොකක් හරි work එකක් කරා කියලා අපි consider කරන්නේ position or shape change under the force. Then draw this one. මේ table එක අඳින්න ඕනේ නැහැ. නිකම්ම අඳලා 1 newton 1 meter කියලා දාලා ඊට පස්සේ answer එක ලියන්න මෙන්න මේ විදියට. අපි මෙතනදී ලියුවේ. මේකත් ආයෙ දෙන්නම්. මෙන්න මේ විදියට ලියන්න. 1 newton. You have to write the multiplication mark. I use this star because I can't find it here. And 1 meter is equal to 1 newton meter equal 1 joule. Okay, so write it. Then after that write this blue color box. Therefore, work done by force equal force multiplied displacement in the direction of the force. So after that write the example 1. Work done equal, what is the force? It's 7.5. Then what is the displacement? If force of 7.1 Newton acts on an object and it displaces by what? 8 meter in the direction. So you have to multiply it and put the answer in joule. Okay, so it's 60 joule. Then example 2, the force is 40 Newton and vertical distance 2 meter. The weight of an object is 40 Newton. That means it acts below. weight එකක් නේ, weight එක act කරන්නේ කොහෙටද? weight එක පල්ලෙහාට තමයි act කරන්නේ. එතකොට ඒ weight එක නිසා යා කොච්චරක් දුර පල්ලෙහාට යනවද? It's 40 Newton. 40 Newton නිසා යා කොච්චරක් දුර පල්ලෙහාට යනවා කියලා කියනවා. The distance is considered as 2 meter. Then 40 into 2, it's 40 into 2, it's 80 and the unit is joule. Okay, so its work done is 80 joule. Then example 3, the mass of an object is 5 kg. Okay. Now they have given you the mass, not the weight. So what is the weight if the mass is 5 kg? Find the work done in lifting it up to upwards by 3 meter. So you have got the distance, displacement. It's 3 meter, and they have given the mass of the object. So you have to convert it into weight. If it's 5 kg, uh, how we convert it to into weight? Mass of the object is mg. So I always tell you, if an object is 5 kg, what is the weight? If the mass of an object is 5 kg, in order to find its weight, we have to multiply it from 10. 1 kg එකක් නම් weight එක 10 newton, 2 kg නම් 20 newton, 3 kg නම් 30 newton, 5 kg නම් 50 newton, 100 kg නම් 1000 newton, like that. මේක 10 වලින් ඇයි මේ m කියන්නේ mass එක, m කියන්නේ මෙතන mass එක, හරිද? ඒක තමයි 5 kg. g කියන්නේ මේ 10 ms minus 2 කියන gravitational acceleration එක. ඒක නිසා තමයි මේක mg වෙද්දි weight එක වෙද්දි 50 newton වෙන්නේ. එතකොට 50 newton multiply 3 meter, it ended up like this. And you have to do this exercise. So after you've done this one, I'm going to go through it and find the errors and corrections. So mark the correction. Correct. I'll do the corrections. Okay. So do this one right now. Pause the video and do. Then let's come back to the part energy. So put the number 2 and energy. So energy is, so after energy, write this one. The ability to do work. Energy is the ability to do work. The unit of measuring energy is the same unit joule. Same unit joule. හරිද? Energy එකක් joule ම තමයි. Okay. Oh, what happened? I don't know, I can't highlight that part. Anyway, it's joule, same unit. We need energy to do various tasks. There are different forms of energy. Different forms of energy. What are them? Heat, electric, magnetic, mechanical. So after you write the ability to do work, then put a star mark and write its same unit. Same unit, පොඩි කෑල්ලක් ගහලා joule කියලා. Then after that, next star mark is different forms of energy. Then below you have to write heat, heat energy, electric energy, magnetic energy, mechanical energy, light energy, and sound energy. So all these types of energy are measured in using joule. Okay. Then out of these different forms of energy, we will discuss mechanical energy here. So here we are going to discuss only mechanical energy. There are two forms of mechanical energy, and they are known as potential and kinetic energy. So let's see, we have heat, electric, magnetic, mechanical, light, and sound. Here we are going to discuss only about mechanical energy. So other types of energy are found in other exams in your textbook, grade 8 and grade 11. Heat comes in grade so you'll be found other types of energies in next lessons, which we are going to discuss up to here. Okay, here we are going to discuss on mechanical energy. So under mechanical energy, so write the topic mechanical energy. Write the topic mechanical energy and write the sentence. There are two forms of mechanical energy. Put a star mark and write there are two forms of mechanical energy, and below write the two forms: potential energy, kinetic energy. Okay, then write another subtopic. Write another subtopic as kinetic energy. Kinetic energy. The energy possessed by an object due to its motion. Due to its motion. Write below. The energy possessed by an object due to its motion. ඒක තමයි kinetic energy කියන්නේ. හරිද? movement එකක් වෙලා තියෙනවා. As shown in figure 18.4, project an object A with a certain velocity along a horizontal floor so that it collides with a light trolley B. After the collision, the trolley would move some distance before coming to rest. Next, project the object with a higher velocity. Now the trolley will move a longer distance before coming to rest. In this case, part of the kinetic energy of the moving object is transferred to the trolley, setting the trolley in motion. මුලින්ම A කෙනානේ move වෙලා එන්නේ. එතකොට එයාගේ kinetic energy එකෙන් ටිකක් එයා pass කරනවා කාටද? අර B rest එකේ හිටපු B ට. When a higher initial velocity is given to the object, more energy is transferred to the trolley and it moves a longer distance. එතකොට දැන් ඒ තමයි kinetic energy එකක් අරන් එන කෙනා. හරිද? movement එකක් වෙනවනේ. velocity එකක් තියෙනවනේ. ඒතර B ඇවිල්ලා rest. එයාට velocity එකක් නැහැ. එයාගේ velocity 0. ඒතර එයාට kinetic energy එකකුත් නැහැ. හැබැයි A ඇවිල්ලා B ගේ වැදුනට පස්සේ A ගෙනාපු kinetic energy එකකින් part එකක් it transmit to B. Then both are moving but less than the previous velocity. A ගොඩක් velocity එකකින් ආවා. හැබැයි B ට transfer වුණාට පස්සේ දෙන්නගෙම weight එකත් වැඩි නිසා velocity එක අඩු වෙනවා. Okay? ඒතර ගිහිලා rest එකකට එනවා. Similarly, push objects of various masses with the same velocity towards the trolley. You will observe that the trolley would move further when knocked on by larger masses. From these results, it is clear that the kinetic energy depends on the two factors, velocity and mass. तर මේ තියෙන පල්ලෙහා kinetic energy එකේ equation එක අපි kinetic energy නිසා අපි ඒකට දානවා මේ ටිකම ලියන්න ඕනේ K කියලා energy ඊට පස්සේ පල්ලෙහෙන් kinetic නිසා K කියලා දානවා because there are different kind of energy as you already know. So for the kinetic energy we put simple K below the E. So it's half mv square. එතකොට m කියන place එකට you have to put the weight, sorry, not weight, the mass of the object, and v is velocity. Okay, so you have to multiply v from v because it's v square. Then when the unit of mass is kg and the unit of velocity is ms minus 1, the unit of kinetic energy is joule. Kinetic energy එක joule වෙන්නේ mass එක kilograms වලිනුයි velocity එක ms minus 1 විදියටයි තිබුණා. If as an example, if they have given that mass is 2000 grams, you have to convert it into kilograms. If they have given that mass is 2000 gram, you have to convert it into kilograms as 2 kgs. Then you can solve the problem. Okay, here they have given 6 kg and 4 ms minus 1. See, I don't read the example, so you have to read it. Normally we read it, but I find the answers from here, the parts which are very important for us to find the answer. The mass of an object is 6 kg. Calculate its kinetic energy when it's moving at a velocity of 4. So 4 into 4 16, 16 into 6 divide half ne, එතකොට අපිට පුළුවන් 16 2 වලින් divide කරාම එනවා or otherwise 16, keep it as 16, then you can divide this 6 from 2 and 3, so 16 into 3 means 48. Then the next example, it is 4 kg and 2 ms minus 1. So here you got 4, here you got 2 into 2 means 4. So 4 into 4 means 16. 16 divided from 2 means 8 joule. Okay. Then exercise, it's very easy. They have given 10 kg and in this scenario they have given the kinetic energy. That means this part has given. So you have to find this V because M has given, kinetic energy has given, that means EK has given, M has given. You have to find the V. Okay. Here it has given from grams and this one is joule. So you have to convert this gram into kilogram first. Okay, now let's come to the next type of energy, potential energy. After write the topic potential energy, write this one below. The energy stored in an object due to its position or due to a change in its form. When we lift an object upward by a certain distance, we perform work on the object. That is, we expend some energy to bring the object into new position. Let us find, okay. මෙන්න මේකයි. දැන් මෙතන 3 kg නේ. එතකොට you know it is 30 newton. 30 newton තියෙනවා. 30 newton එක 2 meter. ඒතර අපි මෙයාව මේ වෙනම පොසිෂන් එකකට අරන් ගිහිල්ලා යාට දෙන එනර්ජි එක තමයි මේ potential energy කියන්නේ. හරිද? 30 newton ගන්න දැන් දන්නවනේ. 3 kg නම් ඒක mg නේ. mg කියන්නේ m නම් m කියන්නේ mass එක 3 kg. G කියන්නේ gravitational force එක. ඒක 10 ms minus 2 gravitational acceleration. Gravitational acceleration, not force. Okay, gravitational acceleration, it is 10. So after you multiply 3 from 10, you get 30 newton. So it is okay. In this way, you can find it using this simple equation. Potential energy. See, this m is, so this is same as the work done නේද ළමයි. 30 newton 2 meters ගියා කිව්වම අපි මේක multiply කරොත් අපිට එනවා 60 joule. එතකොට මේ විදිහටම තමයි potential energy එකත් හොයන්නේ. බලන්නකෝ. m ඉන්නවා, g ඉන්නවා. mg කියන්නේ 3 kg gravitational acceleration එකෙන් වැඩි වෙලා 30 newton වුණා. height එකෙන් වැඩි කරා h 2 meter වලින් වැඩි කරා. එතකොට 60 joule වුණා. හරිද? m එක මෙන්න මේ ටික ලියා ගන්න. මේකත් ලියා ගන්න ඉස්සෙල්ලාම. ඊට පස්සේ m is the mass, g as the acceleration due to gravity. Gravitational acceleration කියලා ලියුවත් හරි. h කියන්නේ vertical distance. එතකොට මෙතනදී වෙනස වෙන්නේ h always it is vertical distance. අපි එකම පැත්තට තියෙන distance එක ගත්තනේ, ඒකත් ගත්තනේ work එකේදී පළවෙනියෙන්ම discuss කරපු පාඩමේ start එකේදී discuss කරපු work එකේදී මතකද 1 newton object එකක් 1 meter ගෙනියන්න. 2 newton object එකක් 1 meter ගෙනියන්න. ඒ ඔක්කොම අපිට ගත්තේ horizontal distance එකකින්. හැබැයි අපි දැන් මෙතනදී h එක ගන්න vertical distance එකකින්. මේ potential energy එකේදී අනිවාර්යයෙන්ම කොතනට හරි උස්සලා හරි කොතනින් හරි පල්ලෙහෙන් තියලා හරි most of the time you have to lift it upward. එතන එහෙම ගන්න එකක් height එකක් තමයි vertical distance එකක් තමයි potential energy එකේදී අපි always consider කරන්නේ. හරිද? ඊට පස්සේ මේ තියෙන example 1 මේක ගන්න. example 1 කියලා දාලා 7.5 kg vertical height එක 4. එතකොට 7.5 kg එනවා. gravitational acceleration එක 10 එනවා. height එක 4 meter එනවා. answer එක 300 joule. මෙතන බලන්න 200 gram 200 gram කියන්නේ ඒක divide කරන්න ඕනේ kilogram වෙන්න 1000 වලින්. එතකොට 1000 වලින් divide කරාම 0.2 gram. ඊට පස්සේ kilogram වලට convert කරන්න අපි 1000 වලින් divide කරන්නේ. ඊට පස්සේ ඒක mg එකෙන් වැඩි කරනවා gravitational acceleration height එක 4. එතකොට 0.2 ඒක 10 වලින් වැඩි වුණාම 2 වෙනවා 2 into 4 8 joule වෙනවා. Instances where potential energy is used in daily life. හරි මම මේ ටික කියලා දෙන්නම් power එකත් එක්කම දැනට ඔය ටික ලියා ගන්න. Okay. miscellaneous exercises තමයි ඊට පස්සේ එන්නේ නේද? ඊට ටික මම කියලා දෙන්නම්. Instances where potential energy is used in daily life එකයි. instance තුනක් තියෙනවා. ඊට පස්සේ power එකට එනවා. ඒ ටික මම කියලා දෙන්නම්. ඊට පස්සේ miscellaneous exercises තියෙන lesson එක ඉවරයි. ඒ ටික මම කියලා දෙන්නම්. එතකන් අර note එක ඒ විදිහට ලියා ගන්න සහ මේ ටික තේරුම් ගන්න. Okay. I'm going to upload this one and share the link with you.